Welcome to the 7th session of the circular function series. In this session, we will present how to apply properties of circular function such as angle addition formula, supplementary and complementary relations, as well as various algebra techniques to solve more challenging questions. We will demonstrate 12 worked examples in this session.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to the 7th session of the circular function series. Example 1 is to evaluate cotangent theta, given that sine theta plus cosine theta equals 1 over 5, where the angle theta is between 0 and pi. Since sine theta plus cosine theta equals 1 over 5, we may obtain the value of sine theta cosine theta, which equals negative 12 over 25. And this can be done by applying the squares on both sides of the equation, and then rearrange the equation to obtain. Let's come back to the original equation. Sine theta plus cosine theta is also written to square root 2 times sine theta times square root 2 over 2 plus cosine theta times square root 2 over 2, or in parentheses as seen on the screen. As we know, square root 2 over 2 can be written to sine pi over 4 or cosine pi over 4. Hence, we may use the sine addition formula to simplify the equation to sine theta plus pi over 4 equals 1 over 5 square root 2. Since cotangent squared theta plus pi over 4 equals the reciprocal of sine squared pi over 4 plus theta minus 1, which gives the result of 49. According to the early calculation that sine theta cosine theta is less than 0, and at the same time sine theta plus pi over 4 is greater than 0. So the angle theta is located in the second quadrant, and cotangent theta plus pi over 4 equals negative 7. After applying the cotangent addition formula, we have the equation of cotangent theta minus 1 all over the sum of 1 and cotangent theta equals negative 7. After solving this equation, the value of cotangent theta is obtained, which is negative 3 over 4. Example 2 is to find the minimum and the maximum values of the function fx equals cosine squared x plus sine x, where the modulus of x is less than or equal to pi over 4. Since the domain of the function is between negative pi over 4 and pi over 4, and according to the Pythagorean identity relation, the function is written to fx equals negative sine squared x plus sine x plus 1, which can be written in its turning point form, negative 1 times sine x minus 1 over 2, or in parentheses squared, plus 5 over 4. Based on the quadratic turning point form and the given domain, the minimum value of fx is 2 minus square root 2 all over 2 when x equals negative pi over 4. The maximum value of fx is 5 over 4 when x equals pi over 6. The criteria in example 3 is that cosine theta equals k and the theta is between 0 and pi over 2. The question is to evaluate 3 cosine functions that need to be converted to their corresponding first quadrant angles to obtain the cosine function values. As for the first function, since cosine pi plus theta equals negative cosine theta, it equals negative k. As for the second question, since cosine 2 pi minus theta equals cosine theta. It equals k. As for the last question, since cosine pi over 2 plus theta equals negative sine theta, it equals negative square root of 1 minus k squared. Example 4 is to prove that sine theta minus cosine theta equals plus or minus square root 2 times sine alpha, given that tangent alpha equals the ratio of sine theta minus cosine theta, or over the sum of sine theta and cosine theta. To prove this relation, we need to think how to relate sine theta, cosine theta, and sine alpha based on the given criterion. Since the reciprocal of sine squared alpha equals cotangent squared alpha plus 1, this is the direction which leads our proof. We start to express cotangent alpha, which is the reciprocal of tangent alpha. Hence, sine squared alpha equals 1 over the sum of cotangent squared alpha and 1, which equals the reciprocal of the sum of the ratio of sine theta plus cosine theta, or to the result of sine theta minus cosine theta, or in parentheses squared and 1. The expression can be simplified to the ratio of sine theta minus cosine theta, or in parentheses squared, to 2. Hence, sine theta minus cosine theta, or in parentheses squared, equals 2 times sine squared alpha. After taking square root on both sides of the equation, we have proved the relation of sine theta minus cosine theta equals plus or minus square root 2 times sine alpha. The criteria in example 5 is that tangent alpha equals 3 and alpha is located in the third quadrant. The question is to evaluate sine alpha and cosine alpha. Since tangent alpha equals 3 and alpha is located in the third quadrant, cosine alpha equals negative 1 over square root of tangent squared alpha plus 1, which equals negative square root 10 over 10. Hence, sine alpha equals negative square root of 1 minus cosine squared alpha, which equals negative 3 square root 10 over 10. Example 6 is to prove the trigonometry identity relation of 1 plus cotangent x minus cosecant x, or in parentheses times 1 plus tangent x plus secant x, or in parentheses equals 2. We start from the left hand side by transferring all the trigonometry functions to sine x and cosine x. After combining the fractions into one fraction in both parentheses, it becomes sine x plus cosine x minus 1, or over sine x, then times cosine x plus sine x plus 1, or over cosine x, which can be further simplified to 2 sine x cosine x over sine x cosine x, which equals 2. Hence, we have proved the relation as required. Example 7 is to simplify a trigonometry expression. The first step is to modify the expression to the ratio of the result of 1 minus sine to the 6th of alpha plus cosine to the 6th of alpha, or in parentheses to the results of 1 minus the sum of sine to the 4th of alpha and cosine to the 4th of alpha, or in parentheses. Then on the numerator, we may apply the formula of the sum of two cubes to factorize sine to the 6th of alpha plus cosine to the 6th of alpha, which equals sine squared alpha plus cosine squared alpha, or in parentheses times sine to the fourth of alpha minus sine squared alpha cosine squared alpha plus cosine to the fourth of alpha. As for the denominator, sine the fourth of alpha plus cosine the fourth of alpha can be written to sine squared alpha plus cosine squared alpha, all in parentheses squared, minus 2 sine squared alpha cosine squared alpha. Hence, the original expression can be simplified to the ratio of sine squared alpha cosine squared alpha to 2 sine squared alpha cosine squared alpha, which equals 3/2. Example 8 is a multiple choice question, and it asks which of the 5 expressions is not equal to tangent pi over 5. Now, let's look at these expressions one by one. As for expression A, sine pi over 5 over cosine pi over 5 equals tangent pi over 5, according to their definitions. As for expression B, the reciprocal of cotangent pi over 5 equals tangent pi over 5, according to the relation between tangent and cotangent functions. For expression C, since cotangent 3 pi over 10 equals tangent pi over 2 minus 3 pi over 10, which equals tangent pi over 5. As for expression D, since the expression equals the ratio of the sum of tangent pi over 10 plus tangent pi over 10 to the result of 1 minus tangent squared pi over 10, it can be simplified to tangent pi over 5, according to the tangent double angle formula. For expression E, as similar to expression D, we may apply the tangent double angle formula to simplify it, so the expression equals tangent 4 pi over 5, which equals tangent pi minus pi over 5, which equals negative tangent pi over 5. In summary, the expression E is not equal to tangent pi over 5. Example 9 is to prove the trigonometry relation as shown on the screen. We start from the left side by multiplying sine squared x on both numerator and denominator, and then the left side becomes 2 sine squared x minus 1 all over the sum of 1 and 2 sine x cosine x. At this point, we can substitute 1 by sine squared x plus cosine squared x on both numerator and the denominator. Then the expression is further simplified to sine x minus cosine x all over the sum of sine x and cosine x, which exactly matches the right side. Example 10 is to solve two circular equations given that all the angles are between 0 and 2 pi. As for the first equation, cosine squared x is replaced by 1 minus sine squared x. Then the equation becomes 6 sine squared x plus sine x minus 1 equals 0, which is factorized to 2 sine x plus 1, or in parentheses times 3 sine x minus 1, or in parentheses equals 0. Hence, we may apply the null factor law to obtain the x values that satisfy the equation. Here we continue to work on equation 1 of example 10. When 2 sine x plus 1 equals 0, sine equals negative 1 over 2. So, we may use the general solution formula here to express x value, which equals n pi plus negative 1, or in parentheses to the power of n plus 1, then times pi over 6, where n is an integer. Hence, x sub 1 equals 7 pi over 6 when n is 1. X sub 2 equals 11 pi over 6 when n is 2. When 3 sine x minus 1 equals 0, sine x equals 1/3. Hence, x equals n pi plus -1, or in parentheses to the power of n, then times arc sine of 1/3. So x sub 3 equals arc sine of 1/3 when n is 0. X sub 4 equals pi minus arc sine of 1/3 when n is 1. In summary, x equals 7 pi over 6, 11 pi over 6, arc sine of 1/3, or pi minus arc sine of 1/3. Here we continue to work on equation 2 of example 10. The first step is to replace secant squared x by 1 plus tangent squared x. So the equation becomes 3 tangent squared x minus 5 tangent x minus 2 equals 0, which is factorized to 3 tangent x plus 1, or in parentheses, times tangent x minus 2, or in parentheses, equals 0. Now we are going to apply the null factor law to find x values. When 3 tangent x plus 1 equals 0, tangent x equals -1/3. Hence, x equals n pi minus arctangent of 1/3, where n is an integer. Based on that, x sub 1 equals pi minus arctangent of 1/3 when n is 1. X sub 2 equals 2 pi minus arctangent of 1/3 when n is 2. In case of tangent x minus 2 equals 0, tangent x equals 2. So x equals n pi plus arctangent of 2, where n is an integer. Based on that, x sub 3 equals arctangent of 2 when n is 0. X sub 4 equals pi plus arctangent of 2 when n is 1. Hence, in summary, x equals pi minus arctangent of 1/3, 2 pi minus arctangent of 1/3, arctangent of 2, or pi plus arctangent of 2. Example 11 is to simplify a trigonometry expression containing sine alpha, cosine alpha, and tangent alpha. After careful observation, we find that the two complete squares in the numerator may be simplified after being expanded. So the numerator is simplified to 4 sine alpha cosine alpha. There is a common factor sine alpha between the two terms at the denominator. After taking out the common factor sine alpha, the expression of the denominator equals sine alpha multiplies the result of the reciprocal of cosine alpha minus cosine alpha. Hence, the original expression equals 4 cosine squared alpha over the result of 1 minus cosine squared alpha, which is further simplified to 4 cotangent squared alpha. Example 12 is to simplify a trigonometry expression given that the angle alpha is between 0 and pi over 2. The initial observation helps us to find the expressions inside both square roots are complete squares. Hence, the original expression is simplified to the modulus of sine alpha minus cosine alpha plus the modulus of sine alpha plus cosine alpha. At this point, we need to discuss the value range of the angle to further simplify the expression. So when alpha is between 0 and pi over 4, the expression is written to cosine alpha minus sine alpha plus sine alpha plus cosine alpha, which equals 2 cosine alpha. When alpha is between pi over 4 and pi over 2, the expression is simplified to sine alpha minus cosine alpha plus sine alpha plus cosine alpha, which equals 2 sine alpha. Hence, we simplify the expression as required. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.